worked again. I'm always like just in complete awe when everything works. Anyways, I'm 2 minutes early, so if you join a little bit late, maybe come back in so you can hear me tell you what a good job you're doing. I'm very pleased with this group. This is my best group of Advanced Math 2 students so far. I'm gonna kind of just sit here and be quiet for 2 minutes and work. You'll just see me working because, well, because I'm waiting until it's actually time. It all happened faster than I thought it would. I think I have one person. You want to say hi so I can see who's here? I can see that I have viewers, but I never know who they are. And I can say hi back since I'm going to wait until 8:30 to start officially. The awkward part of how long a minute can take. Let's go to our course page. This isn't our course page. We'll get rid of that one. This isn't our course page. We'll get rid of that one. This is our course page. You can always tell how busy I am. I'll put this down for a second by what's on my desktop. So like, do I have my desktop cleaned up? Right now it's not so bad. I have the Advanced Math 1 kids test feedback. It's okay. So I've had a reasonable week. There's my dog coming in the house. Hi, Shifty. All right, 8:30, so we can officially start. So I clicked on, I'll go back a page. I just clicked on, right underneath this YouTube live event is your project for Unit 2. So there's two parts to this. There's a B level part and an A level part. And somebody was already asking, how do I see it? So you click on this PDF and it'll download to your computer. And so what we're doing here is, I don't know, one of the cooler things I think of when I think of polynomials is I think of roller coasters. So ignore the fact that it says Unit 4. They rearranged the unit order. So this is Unit 2 and I didn't want to retype it. Sometimes I can be lazy in that way. So what we're going to do is there's problems that have to deal with roller coasters to kind of help you get your idea of how you might design your own. And so the A level part includes the problems and the design. And if you're only going for the B level part, then it's just the problems. So one question was, where are the problems? Just scroll down and you'll start to see the problems. So the first part here is just, it's working through different kind of roller coaster designs and what they would be. So you can go through, I don't think I need to read each problem with you. You'll go through and answer the questions. And it goes through all the things. This is really a pretty good way of measuring mastery in itself of what you're doing. If you get stuck on a problem, of course, ask me. This is the part that is trickier, and this is why it's an A-level thing. So you're going to design your own roller coaster, all right? And it says, these are the minimum requirements. You must have at least 3 relative maximums and minimums. So I'm just reading right here. All right, your ride must be at least 4 minutes long. The roller coaster starts at a height of 250 feet. So kind of think you're always thinking in feet here instead of meters. The ride dives below the ground into a tunnel at least once. All right. Now, what I really recommend is using Desmos to play around with this, because in Desmos you can use a lot of sliders to play around. But in those things, so it says, this is what they told you. Use a clean sheet of paper to complete the following tasks to write your report. Label each part clearly. Your word must be neat, organized, and appear professional. I'd really like the, the end drawing of your roller coaster. I would like to put those on our course page, as we would hang something if we were hanging it up in the classroom. So draw a rough sketch of your roller coaster on a coordinate plane. Be sure to illustrate your x-axis and y-axis scale to identify the length of the ride and the height of the ride you are designing. Make sure your design meets all these criteria up here. List all the zeros. So what I kind of would like is that, on one piece of paper you have the roller coaster design, so we can post that. And then on another sheet, you're starting to list all these things out. List all the zeros or roots of your polynomial. Be sure to include at least one of each of the following. One double root, so something that has a multiplicity of 2, at least 2 real roots, and imaginary roots. It might be necessary to go back to your design and modify it according to these root requirements. So you might have to, that's why I said playing around with Desmos first might help you. Write the completely factored form of your roller coaster design. Find the equation in standard form. Perform long division or synthetic division to verify the correctness of your equation. Describe the end behavior and the reason for this behavior. Draw an accurate graph of your polynomial. State the practical domain of your graph. That's the actual ride. The practical range of your, that's the actual ride. Because you're going to see in the examples above that the polynomial itself may model a much longer polynomial, not just what you want for your roller coaster. Color the graph blue where the polynomial is increasing and red where the polynomial is decreasing. Identify increasing, decreasing, and constant intervals. All right, so you can see this incorporates a lot of Unit 1 and what you learned in Unit 2. So we get to review and we get to put together how all of this is working. So I'm going to go back where I can see if there's any questions. So I only have one viewer. I think a lot of people are in class. So if there's a question, let me know. And if not, if we don't have any other questions, then I'll just leave this up on the Moodle page for you to see later. And of course, I'm always here to answer questions if you have them. I'm watching just to see if I get any questions. All right, I think it's okay. You can write me on Teams if you have questions, and good luck with the project. I really look forward to seeing what you send.